guys. Hello to everyone. So I hope you are not asleep, and the main goal of this presentation is to wake you up and to not bore you. So first of all, I will check if you are not asleep. Who watched that movie? Oh, almost everyone. So you understand the jokes. Who will not understand, please watch the movie. It's a Okay, the topic is Bandwidth Manager with Mikrotik. I am Groot. It's not me. It's the guy who helped me to find the right pictures and the slides. So you remember the movie. If he will find a different, incorrect picture, it's not my fault. It's his fault. Okay, a few boring words about myself. I do Mikrotik trainings sometimes, not often. I sell the Splynx software to internet providers, and I do BGP, OSPF, MPLS setups. Sometimes I do Mikrotik presentations, and I speak Russian, Czech, English, Spanish. Originally I'm Russian, so I'm quite tired already. If you will not understand me, so it means that I switch to Russian, so just say, Alex, switch back to English, okay? Good. Yeah, this is some picture when I'm training people in Cape Town a few weeks ago. There is a list of customers who are using Splynx software in South Africa. It's around 50 companies already. So I have a stand there, you can talk and I can show you how the system works. But that's not related to the presentation. So you have your popcorn, we can start. So let's start. So I will talk about the bandwidth management today. And the whole bandwidth management is based on policing and shaping. So the policing is when we have some traffic that is reaching the certain limit, we just cut the traffic out, so we drop packets. And the other is shaping when we put it to some bucket, to some queue, and then we process that queue, the Mikrotik processes that queue. So the policing and shaping is the first concept of bandwidth management. And the Groot helped me to find a picture for showing what is the difference between it. So that's a policy. Oh no, it's a politics and shaking. Man, Groot, why you did it? Drop or put to bucket. I think one guy was already dropped. The second one should be as well. No, now seriously. The policing is, you see here we have, like for example 5 meg, and everything what is above 5 meg we simply silently drop. It means that UDP packets are lost and the TCP connections are re-established. And if we have a shaping, then this traffic which is over the limit is not dropped, is put to some bucket, to some queue, and then this queue is moved. Next second the packets are moved out from that queue, and so it's not silent drop. We will talk about shaping today, and shaping, it's a queues concept on Mikrotik, HTB, PCQ, all these words. We'll start with the queuing. I will explain a bit different types of queuing and when to use each single type of queue. So first, Groot again shows us the picture. It's all about queues. Groot, come on, he's a tree, he likes apples, you know, so that's why he put that picture, but it's not the right queue. The right queue is this one, so this is Mikrotik queues. You see the Mikrotik queues when they are red, as you know, I think, it's already reaching the limit. When they are green, it's still fine. So this is example of simple queues limiting customers per giving them 460 kilobits per second speed. So what to manage with like if we talk about bandwidth management, what do we need to manage? The first thing that is used in internet provider networks is limiting customer speed. So you sell 5 megs, you need to cut the speed to 5 megs, or you sell 1 meg, or some guys sell 512 still. They must cut it to 512. The second usage of that bandwidth management is you can allocate bandwidth to some applications. For example, the voice can get 250 kilobits, and it will be dedicated bandwidth to that voice service. And you can set up priority that the voice packets will always go out from the interface as the first, and other traffic will go after it. The Mikrotik shaping has 4 different approaches, 4 different technologies that you can do these speed limitations. I will now talk about just speed limiting of customers. So we can limit the speeds of the clients, and I will talk about performance of each single type of this shaping. So you will understand, if you have 1,000 subscribers, what kind of equipment I need to provide to run the PPPoE sessions and have a shaping. So this I will try to explain now. The first type is Q3. The second one is it's like also Q3, but it's called PCQ with address list. Third is the simple queue. And the last one is simple queue with implementing parents. So the Q3, let's take a look on the Q3. Not Q3, come on. But it's cute, no? Q3, that's right. Q3, we need to mangle all our connections. So if I have 600 customers, I need to create the mangle where I mark the packets for each single customer, which will create, for example, 1,000 mangle rules. And each mangle rule is consuming the CPU resources. I can build the trees with multiple levels, and I can use this type of queue for priority the traffic or provide a double clause, for example. But it's not good in Cloud Core. Everyone is using Cloud Core now, so everyone can buy the Cloud Core, install it, and use. So if you will build the queues with Q3, it will not work well because of the mangles, because too many mangles we have to process, and it will simply die. Okay, that's where the all queues are made on the HTTP global, is the logical chain that is located in Mikrotik. And you see that simple queues were moved out from the HTTP, and it's completely independent now. And so that's how you do shaping with Q3. So mangle the packets and then create plenty of Q3's rules in the HTTP global. This is the example of why it's not good. Okay, so that's 600 mangle rules is increasing the CPU usage of Cloud Core to 100%. So it means that's really not good. And here, for example, it's 200 megabit per second. You can see this is the live screenshots from working Cloud Cores. 100% CPU usage on 200 megabits per second, and it's 640 mangles. So it means this is something what will not work well for you. But as I'm saying, for making priorities, doing it on the CPU, on access point, whatever, that can work. But if you put the central shaping on the Cloud Core, that type of speed limitation will not work well. So that's why we need to check different approaches. Yeah, that's again enhanced Q3. So you see it's a tree, but with some other options. It's a PCQ with address list. The difference is that less mangles we need to mark the packets. We use internal PCQ subqueues, so it means that instead of creating 650 queues and mangles and queues, we can just create 10 mangle rules and, for example, 10 queues. So it will be just 20 rules, and that will manage the whole speed limitation. That approach was used a lot in the past when simple queues in the RouterOS 0.5 version were slow. And now they improved it, and this type of queuing is used now still, but on x86 routers. What is the reason to not use it on Cloud Core? The reason is because Mikrotik is saying that, yes, they have multiple cores, but the problem is when they build one queue, the one CPU only take packets out from one HTTP tree. So it's not working well on high speeds. So as soon as we get like 500 megs, 1,000 customers, Cloud Core will start giving us issues. And Mikrotik is working on updates of the algorithm, or probably they will change it. And what they suggest is to use simple queues instead of this type of shaping. But this is the type of shaping that was used a lot in the past, during the last 10 years. Everyone was telling that PCQ with address list is the best option to limit the speed on 1 gigabit per second. So now I'm talking about really like high speeds. I'm not talking about setting router with 100 megs. Like 1 gigabit per second, 2 gigabit per second. This will work, but as soon as you got a powerful equipment like x86 with a good cores that can process that traffic. But we need to achieve good performance on Cloud Core. So how to do that? The third type of queues is a simple queue. This guy. He is simple, he is strong, so this is what we are looking for. Simple queues, still sequential, but matching algorithm was updated, and it's very fast in Cloud Core and in the version RouterOS 6. We have multiple core support, and we can use radius. So for example, we create a PPPoE session, and automatically via radius attributes, like here, radius attributes we use to set up the speed. So the queues are created dynamically. So we have, for example, 500 customers, 500 queues, simple queues created by radius. And radius also allows us to change the speeds on fly. So it's like COA support. It's a change of authorization, I think. It allows us also to provide a cap and FOOP implementation. So these simple queues with the radius, they work really good. So this is something what I recommend you to use. And some examples. So this is just a screen where I'm showing how we can apply the cap and how we do it in our software. So we change on fly the speed of customer as soon as he reaches certain limit of data. And this is the, it doesn't show it's a 2000 queues at the moment on that router. 2000 queues and 4% of usage of CPU. So you see that this amount of simple queues will not kill the Cloud Core, and 300 megabits per second on 2000 queues will give us 12% of CPU usage. So this is an example from the real Cloud Core, because I'm managing a lot of networks for my customers. I mean, we deploy the software and I have access to their equipment, so I can see what is the actual throughput and what is the actual CPU usage and how it performs. So the performance limitations are this. So if I have Cloud Core 136 in production and I'm running the maximum amount of combination traffic and PPPoE sessions that I can run on that equipment is around 1,400 PPPoE sessions and 1 gigabit per second download and half upload. So on this scenario, we will reach 80–90% of CPU usage, which will start degrading the service. So this is the maximum what we can get from this device. Of course, if I will remove the PPPoE completely from that router, it will give me more performance. But now I'm talking about the scenario that is used really a lot, almost everywhere. Everyone has a PPPoE, everyone creates the queues using radius or using the profile on Mikrotik. And this is the limitation, guys, that you will see as soon as you will reach this amount of traffic on this amount of PPPoE session. So that's why when you are when you are designing your network, you always must have in your head this amount of traffic that you can send through the router, because if you will send more, your customers will start to complain. What about 1072? It's almost double. So we got 3000 PPPoE and queues, and 2.5 download, 1.5 upload gigabit per second, and again we reach the 80–90% of CPU usage. It means that some CPUs, small CPUs, are running on 100%, and the customer are starting to get issues. This is real from numbers from real practice, from the real networks all around the world. Now, this is just an example that I'm not telling you something what I haven't seen. So this is the one Turkish provider that we work together. And this is the DSL network. And they have, you see, this is the 5 routers, for example. They have 1,000 subscribers on each. And the traffic is from 1 gigabit, around 1 gigabit. And the CPU usage is, as I shown, is like up to 80% sometimes. Yeah, this is the traffic on one interface is 500 megabits per second. So we have another option also. So the first simple queue is good to use. Please use it everywhere. If you want to improve it, there is a way how to improve it. You can use simple queue with parent. So the parent is another queue that you can set up, and then when you are creating your queue for clients, you just put the parent value to this queue. And so Mikrotik says that it's 9 times faster than simple queue. because each parent and children are managed by different core and less steps needed. So this is optimized design, and it optimizes usage of all cores for processing that packets. We can also build contention scenarios on that type of shaping. So it means, yeah, unfortunately, we cannot use radius to set up the parents, because if I know, and I'm not sure if it was updated, but I don't think so, Mikrotik doesn't allow to put the parent attribute to the radius answer. So when we send from radius back the queue speed, there is no way to put the parent. So that's why, for example, in my software, we use API to create the queues, to create that trees for contention, and contention can be different types of contention. First of all, we can set up the contention per plan. So for example, we sell 5 megabits per second, and the contention is 1 to 5. So it means that all customers who are under that plan, they will share 5 megabits. I can set up the limit at to 1 megabit per second. It means that they will reach always 1 megabit per second. It's the guaranteed speed. And I can use central shaping. So I can put all my routers coming to, all traffic from all routers coming to 1 or 2 routers. And on that routers, I can create the big queues, and that will make contention of customers. The only one limitation is 128 IPs under one parent that Mikrotik has. Yeah, this is how it looks. So we have a main parent queue where we need to put all IP addresses of the customers. So you see, if you create it manually, it can take a lot of time. That's better is to write some scripts or have a tool that will create it for you. And then the customers, they have 5 megabits also. So as soon as they will start downloading simultaneously, they will share 5 megs, and they will not get more than 5 megs, all of them. So they will get 1 meg each. The second option is we can also do contention per sector or contention per router. So it means we define that the maximum uplink is 10 megs on that router, and all customers will share the 10 megs. And it doesn't matter if their plan speed is 5 meg, 3 meg, it doesn't matter. So this is the design how we can do it. So we put the main parent, which is 10 meg, and under it you can see, if you will count everything together, you will see that it's more than 10 meg. But in fact, they will not use more internet, they will not get more speed than 10 meg in total. So this is contention with a simple queue again. You don't need to build a queue tree as it was in the version 5 something. In the version 6, you have a parents, so you can do contentions that way. What is the QoS with simple queue? The simple queue was enhanced. It was really redesigned. And now it's fast, and it allows you even to make a QoS on it, quality of service. Why we need the QoS? When the link is overloaded. So this guy is overloaded, we need to apply some QoS, quality of service. How we can do it? We can, where to set QoS, the first question. We can set QoS on the main shaper, on the edge, and on the CPE. That edge is access point, for example. The disadvantage of doing QoS on core or on edge is that we always need to specify the maximum speed to make QoS work. And the quality of service will start work only when the main the parent speed has reached. So we need, for example, I have a core router, and it runs 500 megabit per second. And if I want to build the quality of service on it, I need to create a queue which will say the maximum throughput is 500 megabit per second. But that is limiting my real throughput. Maybe it will be 550 or 600, but I will cut it. So that's why I do not recommend to use QoS centrally. I do not recommend to use QoS on the access points as well. It depends on your design. Personally, I prefer to set up quality of service on the CPE device. When the CPE is, for example, 2011 or something, because when we have a QoS, we always speak about customers who really need the QoS. So mainly it's like a corporate customer who has voice, and they need support of the services with a good high level of speed. So that's why we set it up on the CPE. Is the closest point to origination, and also we don't need to, we can set up the parent, but the parent is the maximum speed of this line of the client. So if we sell the client 10 megs, we will set up the parent to 10 megs on his CPE device, and under that parent we will put the rules that will say high priority for DNS traffic, high priority for voice traffic, dedicated bandwidth for voice traffic. And that I suggest to use it on CPE. But you can use it everywhere we want. It's just a suggestion. What you can do with a clause on a simple queue, you can specify the destination IP. So you know when you are creating the simple queue, you always put the target. The target is the source IP. So you can also put the destination IP, which will be IP of your SIP server, for example. And the packets on that queue will know that this traffic goes to a SIP server. I need to put high priority or give dedicated bandwidth to it. So that's the second option. We can set up the guaranteed speed, and we can use priority parent, and even that can work with the marked packets. So few slides more showing how to do that. I have target, and I set up destination IP. So this is the IP of my SIP server. I can set up the dedicated bandwidth, which is called limit add. So if you work with the queues, you know that there is a concept max limit and limit add. So limit add is the dedicated bandwidth to customer or to application or to type of the traffic. I can set up the priority, which is 2 is better than 8. So 8 is the worst priority, 1 is the best priority. So I can set up high priority to that traffic. And the third option that I told about is DNS. I can mark the packets that goes to DNS and allocate to that DNS queries also some bandwidth, dedicated bandwidth. That's all. So my contacts are email address, one website, second website, Facebook and Twitter. And I hope that presentation was not boring. And thank you for your time. Thank you, Mikrotik, for good products and for the conference. Valens is the one guy that I used few slides from his presentation, and thank Groot for the pictures. That's all.